Okay, guys. So this first lesson is just about, what are we doing with rational numbers? This shouldn't take you very long. You're going to take a few notes. I've given you the packet ahead of time, um, not the full packet, but these notes. And really, some of you probably don't need most of this. There's just one section when we talk about simplifying a fraction using prime factorization. And I'm going to be honest with you, I'm not going to require that, but I think that if you see it a few times, you're gonna see the value to it. I might give you a quick worksheet to say, here, simplify all these fractions with using prime factorization. That might be something that I give you just to make sure you can, but I just want you to see the value of it, show it, and then after that, I mean, whatever way you do, just remember I'm trying to show you ways to make less mistakes. When we look at this first one, the biggest thing, what do you notice about these fractions that you've not ever seen before in fractions? And that should be that there's negative numbers. Remember, we're also talking about this symbol also means divide. So when we look at this symbol right here, that bar, that can mean 6 divided by 7. So a negative divided by a negative is a positive, right? So we know that this is really going to be, this is a positive. So it's got to come out to be a positive. We know that this one is not positive. We know that this one's a negative divided by a positive, which is a negative. Now this is a positive divided by a negative, which is a negative. And this one's a positive divided by a positive, which is a positive. So really the only ones that work for this is this one, because this one comes out to be positive 6/7, and the other ones do not. Only this one here comes out to be positive 6/7. When we look at B, we have negative 3/4. So when you quickly pick which one would come out to be negative 3/4. So of course we're looking to see which ones have one negative and one positive, right? Because we're still building off those rules that we just worked on, which is that a positive divided by a positive equals a positive divided by a negative equals a negative, that a negative divided by a positive equals a positive, and a negative divided by a positive equals a negative, and a negative divided by a negative equals a positive. So we're looking for, we have a negative, so we just want to say, well, this is a negative divided by a positive, so that one works because that's going to be negative. This is a positive divided by a positive, so that one doesn't work. This is a positive divided by a negative, so that's going to be a negative, so that works. And this is a negative divided by a negative, which is going to be a positive, so that doesn't work. So the only two that we would check would be those two. Okay, so now look at this one real quick, because we're going to go over what this is, terminating decimal versus repeating decimal. But look at this real quick, pause, and see if you already know, because if you already know this, well, you don't really need to go through much. So just see if you know it. And if you know it, then you can fast forward past my explanation of this. So those should be your results. Terminating means it ends, okay, so that it has an end. It stops at some one point. So you would write in there that a terminating decimal is one that ends, okay? Okay, so a decimal number that eventually stops, okay? So examples of that, write some examples if you can think of them, but, an example of that would be like 4.375, because it ends, right? It stops, or 0.05, 1.78934, right? That it ends, it stops. It doesn't have anything that continues on, okay? And a repeating decimal is a decimal that has a block of one or more digits repeating without end. Okay, so there's a couple things we do with that. So examples of that might be 0, So an example of that could be like 0.444. When you hit that dot, 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 that means it continues on forever. Okay, so you could have 5.151515 dot, dot, dot. It means that pattern, the 151515, that pattern continues on forever, right? And then, so the 2.64444 dot, 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 that continues on forever. That's what the dots mean, okay? So sometimes what we do is we use what's called bar notation with that. So if we were using bar notation with this, then what we would do is we would say that the first one would be 0.4 with a bar over the top, because that means it continues on. And we would write the next one as 5.15 with a bar over the top. And we would write this one as 2.64 with a bar over the top. Notice we don't put the bar over the 6 because the 6 isn't what's repeating, it's the 4 that repeats. Okay. Okay, so some non-examples of repeating decimals would be like 0.1432179621 dot, 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 right? Because nothing in there repeats. This would be a non-example. Okay, a non-example, any one of these, all right, could be a non-example. This is also a non-example of a terminating decimal. Okay, so when we look at this one here, there's no pattern to it, but it just keeps going on and on and on. So it's not a terminating decimal like these, all right, and it's not a repeating decimal like these. So therefore, it must not be. We can't write it as a fraction. We won't be able to write all these numbers here. We can, if it looks like this, or like this is a decimal, we can write those as fractions. If it's not one of those, then we can't write it as a fraction. Like pi. Pi is not a fraction, cannot be written as a fraction. So it's not considered a rational number. Okay? But it's something close. And we consider it 22/7, but that's just for ease in calculation. It would not be considered a rational number because it's not terminating and it doesn't repeat. It goes 3.1415 la 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 on and on and on, right? Okay. Okay, so when you look at these, I mean, I'm thinking you could probably already do this. So why don't you go ahead and write these as decimals? And if you can write all these out as decimals using your own math, you can't use a calculator, but if you can write them one way or another, then go ahead and do them right now, and then you'll be done. I'm going to check to see if you know how to do it. So hit pause, do these, and see if you know how to do it. Okay, so if you really pause and you see that these come out this way, so if you got these all right, then you're good. Okay, if you don't know how you got these, I'll show you right now a couple ways to get them, and then take notes. And it's going to take you a little longer. If you don't know, if you got all of these right, well then fast forward to the next section. So, all right, so when I look at this one, when I look at 3/5, okay, when I look at 3/5, for me, the first thing I want to do, because I know my decimal place value goes tenths, hundredths, and thousandths, right? So, I mean, really simply, I can make this into tenths, because if I just multiply this by 2 over 2, then that's going to give me, it's going to give me 6, because 3 times 2 is 6 and tenths. So, and 6 tenths is just 0.6, and it terminates, all right? Now, hopefully you guys all know this, because after all, a quarter is 25 cents, right? Which is 25 100ths. But you could have also just said, now, so some of you are going to struggle with this, but you're going to set this up, right? And the one on the bottom, this always goes on the outside, and this one always goes on the inside. Now, so this is where some of you are going to struggle, okay, because we're going to be talking about decimals, right? And we're going to put a 4 here on the outside, and we're going to put a 1 here on the inside. And that just doesn't make sense to a lot of people. But remember, we're talking about something that's smaller than 1. 1/4 is smaller than 1. So this should come out smaller than 1. So automatically, I know I'm not going to have anything in here. There's nothing there because it is smaller than 1. So now I look at the 10, right? And I want to know how many tenths if I have 10 tenths, divide that into 4, what am I going to get? I can get 2, right? Which is going to give me 8 tenths. And that's going to give me 2 left over. So now I have 20 100ths, because that's the hundredths place value, right? And that's going to give me 5 times 4 is 20. So that's going to give me 5 100ths, which is 20, which just comes out to 0, right? So when I did my long division, I got 0.25. Okay, when I look at 7/25ths, I look at that and say, well, 7/25ths, and I want to make that into 100ths, because I know, in my head, I know that 25 times 4 is 100. So I'm going to multiply the 7 times 4, and 7 times 4 is 28, and 25 times 4 is 100. So this is 28 100ths, which is 0.28. Okay, so when I look at this next one, I see that's 13 thirds. That's an improper fraction, or what we're going to call a usable fraction. Okay, so I know that that one is bigger than 1. But again, I look and say that the bottom is what goes on the outside, and the top is what goes on the inside. Okay, so when I set this up, then now what I'm doing is I put my decimal there, right? Because that's 13 wholes. Everything else is parts, right? Tenths, hundredths, thousandths. And the first thing I look at is say, well, let's see, 3 will go into 13 4 times. So I can put a 4 here. And 3 times 4 is 12. Which means I'm going to be left over with 1. And then I put a 0 there. Well, 3 goes into, and you were taught to say 10, right? Because that looks like 10. But you got to remember your decimal line's up here, right? So we're really talking about how many tenths will go into one whole. And we're talking about 3, so we're going to have 3, because 3 times 3 is 9, right? And then when we take that away, we're left with 1, right? And so then again, we're going to have 3 again, right? So then we look at that and we say, well, let's see, we have 3 again. So that's all I can use is a 3 up there, right? So I put a 3 up here, and 3 times 3 is 9. Well, this is a pattern. I'm going to just keep getting this. So this is going to be 3, 3, 3, 3, 3 all the way on, right? So this is just 4.3 repeated. That's how you write that as a decimal. If you wrote it like this, that would be okay. Okay, but you need to put that dot, dot, dot there, because that says you understand that this is not a terminating decimal. Okay. And so the same thing you do with 5/11ths. Okay, so first thing I want you to do with this is just fill out the prime factorizations here. Okay, because most of this you should have done on your worksheets to find the prime factorizations. And if you're getting your hundreds charts done, most of that's already done, right? So just figure these out, put out the prime factorizations for these, and then so hit pause, put in the prime factorizations, and we'll go from there. Okay, so there's your prime factorizations. And I've already kind of shown you this, but now you're going to kind of practice it. So if we look at this fraction, right, we're going to take the 28, which is 2 times 2 times 7, right, over the 40, which is 2 times 2 times 2 times 5. And we just ask ourselves, what do they have in common? And if I look, they both have a 2 in common. They have another 2 in common. And so those become 1s. So we wind up with the top being 7, and the bottom 2 times 5 is what's left over. That's going to be 7/10. Okay, so now just put the prime factorization of these two numbers there. So we look down, 34 is 2 times 17, and 51 is 3 times 17. So hopefully you guys figured that part out. So when I look at this, what do they have in common? Well, they have the 17s in common, right? So that makes a 1. And so this simplifies to be 2/3. Okay, so now you do if you do 35 49ths, then what you'd say is, well, 35 is 5 times 7. 49 is 7 times 7. What do they have in common? Well, they have the 7s in common, right? So that means this simplifies to be 5/7. Okay? All right. So the rest of that's the only new thing here that we think we're doing. So these you would makes numbers into improper fractions, or what we'll call usable fractions. So, hey, if you can already do this, just do it now and then hit pause, see if you can do it. If you don't, then, I guess fast forward and see what we can do. Okay, so if you don't know how to do this, then you should be writing this down, and some of you may want to write this down anyway because it helps. Okay, so if we looked at this and said, well, this is one whole, and this is one whole, and this whole thing is one whole, but each one of these is one whole, right? But this would actually represent one because it's filled in, and this is one, and they're broken into 7 pieces or 11 pieces, right? And this is 7/11ths. And this would be, so 1 would be the same thing as 11/11ths. So each one of these is 11/11ths, right? So if this is 1 and this is 1 and this is 7/11ths, then this whole thing is 2 and 7/11ths. But we can also say that it's 11/11ths plus 11/11ths plus 7/11ths, which is 29/11ths. Okay. Now your elementary, this is your teacher's got this, because notice you have 2, right? 2 wholes, which means you have 2 times 11, and then you added the other 7/11ths, and that's where your teacher's got those rules, right? So you say 2 times 11, 11 times 2, which is 22, plus the 7 is 29. But that's where it comes from, all right? Okay, so if we look at the same thing, and we do the same thing we were just talking about, then what we're going to do is we say this is 5 wholes, right? So here's 5 wholes. that are broken into thirds, right? Okay, and then we have 2/3, 5 wholes and 2/3. Okay, so we have 5 wholes and then 2/3, right? So if we're looking at this, this is 5 2/3. But this is also 1/3 here, 3/3 here, 3/3 here, 3/3 here, 3/3 on this one, 3/3 on this one, and 2/3 here. Okay, so all together here, we have 15/3 plus the 2/3, which gives us 17/3, right? Okay, so, and again, in your elementary school, they taught you multiply this, the 3 times the 5, because the 3 is how many it takes to make a whole, times the 5, and then you have to add the 2. So that's 15 plus 2 is 17, so this equals 17/3. But this over here is y, okay? And the last little thing here is whether or not something's an integer or not. So when we look here, if an integer basically is anything that sticks on the line, right? If it's on this crosshair, it's a positive or negative whole number. All of these numbers are integers. Okay? Everything in between there, everything in between here would be called a rational number, if we can write it as a ratio. If it's a repeating decimal or a terminating decimal, we would call that a rational number. All of the numbers in there are called real numbers, but only some of them are repeating decimals or terminating decimals, which makes them rational numbers or fractions, right? And then even less of them are integers because they sit right on those crosshairs. They're positive or negative whole numbers. Okay. Okay, that's it, guys. This is long, but only if you didn't know this stuff. Okay, good luck.